Okay, hi. So good day, everyone. Please excuse my copy. It is in black and white, as that's the only way that my home printer prints. But you do have a copy of this in color on ClassKit. So before we jump into example number 1, I wanted to point out some things just as a reminder. Okay, anytime we are given a quadratic function, we can describe it based on the vertical and the horizontal translations and how it affects the graph. What I wanted you to see here, if we just focus on the vertical transformations, because that's how we started with absolute value functions. If we just look at the vertical transformation here, that happens when we change the k value. Okay, so if k is greater than 0, then what's going to happen is that graph is going to shift up. If k is going to be less than 0, that graph will do a vertical shift down. So vertical up or down. Okay, now on the other hand, with horizontal transformations or horizontal translations, horizontal is what happens inside of the parentheses here. So notice that we do have that same minus sign built in, and I kind of talked about this a little bit on the warm-up. So if you didn't watch that video, you may want to go back and look at that. Okay, so here we go. If h is less than 0, we're going to go to the left. And if h is greater than 0, then we're going to go to the right. But I want you to keep in mind is that there's a negative built in here. So even though this graph here shifts to the left, that would look like x minus 5 or something like that. Then what we would expect to happen is that it's going to be the opposite. So h in that case is going to be the actual 5, and so we would move to the right. But if we needed to go to the left, then it would be a negative 5, because a negative times a negative will give us a positive. If you're still struggling with that, please don't hesitate to let me know. This is, like I said, in color on your ClassKit assignment, where you can see the things in a different light. Okay, so what I have set up for you here is the first example that you have on your ClassKit assignment. So the first example says to describe the transformation of f of x equals x squared represented by g of x equals x plus 4 squared minus 1. Then graph each function. Okay, so what we want to do first, I need to put period there because that's the end of my sentence. Okay, so what I want to start out with first is graphing the parent function, which is f of x equals x squared, and I'm going to do that in black to kind of try to match what you saw on your ClassKit assignment. So give me just a second to set that up. Okay, so even though we did this in section 1-2 with graphing them using a table, I wanted to do this example thoroughly all the way through so you can kind of see what happens. Okay, like I said, I always, not 2, 1, 0, you can pick whatever numbers you want. Okay, I just like to choose really and truly 1, 0, and -1, because I like to know what's happening at the origin and also what's going to happen on the left and the right side of that graph. So you may already know what the graph of x squared looked like, but just in case, if you needed a refresher or a review, what I would do is plug in 0 for x. 0 squared is the same thing as 0 times 0, so that's just 0. So I know for a fact at the origin I'm going to have a point at 0, 0. Okay, then I would look and see, well, what happens at 1? Well, I would do 1 squared, which is the same thing as 1 times 1. So that's going to give me a 1 for f of x. So at 1, 1, we'll have a point. Okay, then I would do the same thing with 2. 2 squared, which is 2 times 2. Oh, my gravy. Why did I write that like that? Haha, white out. That's going to be 4. So at 2 to the right and 1, 2, 3, 4 up, I have a point. Okay, so that's my positive side of my graph. Then I want to see what happens at a -1 squared. So a -1 squared becomes -1 times -1. Well, 2 negatives multiply and you get a positive 1. And it is the same thing for a -2. If I need to square that, then that's going to be a -2 times a -2, which is going to be a positive 4. Okay, so in, uh-oh, I didn't put my 4s. All right, so what happens is that this graph is symmetrical. It reflects across the y-axis, which this is my y, and over here we have our x-axis. So then at 2, 4, I'm going to have a point. Okay, give me just a second. I'm going to slide this off screen so that I can kind of draw it in a little bit for you. Okay, so believe it or not, I did my very best, and this is my graph of f of x equals x squared. So let's go here, and I'm going to write it here. F of x equals x squared. If you ever need to know which graph we started out with, that's our parent function of our quadratic. Okay, so here we go, our U-shaped graph. Now what we want to do is we want to look at what is going to happen when we graph g of x equals x plus 4 squared minus 1. So give me just a moment. I'm going to set that up. It's going to kind of be off the screen because I want to keep it on the same page, okay? So give me just a second. Okay, so I kind of set it up off camera, but I wanted to do a few of these together. So here we go. I'm going to first look and see what happens at the origin for x. What will the y value be, or what will my output be if my input is 0? So to set that up, I don't know what y is going to be or what g of x is going to be when I let x be 0 plus 4 squared minus 1. Okay, so I would start on the inside, parentheses first, and this will give me 4 squared minus 1. Well, 4 squared is 4 times 4, not 8. It is 16. 16 minus 1 is 15. So when x is 0, our y value is 15. Now, okay, so I cut myself off right there. I wanted to talk about what's happening. Our graph is a 10 by 10. 0, 15 is going to be way off of our graph. Now, if anything happens like what we expect to happen here, 0, 15 will be way up here. So that lets me know that we are way off of our graph. So what I want to do now is look and see what happens here when our x value is, let's say, a negative 2. Let's look and see what's going on over there. So I'm going to let x be a negative 2, and I'm going to plug that in. We need to know what is g of a negative 2 when we plug that in here. So we're going to have a negative 2 plus 4. That's going to be squared, and we're going to subtract 1. I just replace x with a negative 2. So here we go. Starting in the parentheses, negative 2 plus 4 is 2. We're going to square that and subtract 1. So we're going to get 2 squared is 2 times 2 is 4. 4 minus 1 is going to be 3. So g of negative 2 is a positive 3. Well, that will fit our graph. So let's see here. Let's move a little bit further over and see what happens when x is a negative 4. So I hope you're noticing that we're going to the left side of the graph, which kind of fits what we know about horizontal transformations. Even though that's a plus 4, it's understood to be a minus 4. So here we go. I'm going to do this one on camera for you so that you can see it done. G of negative 4. That is going to be a negative 4 plus 4 squared minus 1. So we're going to have negative 4 plus 4. That's 0. And 0 squared is just 0. 0 minus 1 is a negative 1. So when x is a negative 4, our y value is negative 1. Let's see if we can kind of sketch some of those things out. Okay, so I'm going to pause it, and then I'll be right back at the start of my graph, which is here. So we have 0, 15, won't work. Negative 2, 1, 2, and up to 3, 1, 2, 3. We'll have a point right in there. And then at a negative 4, so 1, 2, 3, 4, and down to a negative 1, we have a point there. Okay, So things have shifted a whole lot. We went from the origin down to a -1. Let's see if we go further down. Okay, I would plug in a -6 maybe to see what's going to happen here. Okay, so I'm going to do that off camera. I decided why not do it on camera for you so you can see it. A -6 plus 4 is going to get, wait, it seemed like that's out of focus. Excuse me. -6 plus 4 is going to give us a -2. And a -2 squared minus 1. Well, a -2 squared, I'm going to write this out because I think it's good practice. That's a -2 times a -2 minus 1. Well, a -2 times a -2 will give us a +4 minus 1. And so we're back again at 3. Okay, so I'm about to sing a song. Excuse me, folks. -6, +3. Oh my God, back at it again. That's what popped in my head. Okay, so -6 and a +3. So at the origin, we're going to go 6 to the left. 1, 2, 3, 4, 5, 6. And up to 3. 1, 2, 3. Boom. Okay, so now we got some things happening over here. Oh man, I was hoping that the green would show up a little bit better. So I am going to draw my graph in as best as I can. I would encourage you to do the same thing. I mean, I mentioned it before, but I know graph paper was not on your list of things to purchase for this school year. And if we were on campus, I would give you some graph paper. But you just do the best you can, you know, make your sketch. Do your best, and don't forget you do have decimals there that can check your work. Okay, so this graph that you see here in green is our graph, and I'm not going to write it all the way out, of g of x. Okay, so what has happened? Okay, so if I were to, give me just a second, I want to write something down. Okay, good people, I wanted to write it down so that you can kind of see it a little bit better. I lined up everything in here. This part right here is what we want to focus on right now. It's very important. Okay, so what I started out with here, this is called vertex form. And I don't think we addressed that just yet, but I just wanted to put it in your memory bank. This is no, oh my gosh, it smeared. That was not intentional. Okay, but what I want you to see is that notice there is nothing here in a value of a. That a is just the 1. Okay, so 1 times anything is just that anything. It does not affect the graph at all. But what happens is in the place of k, let's start with k. K is the easier one. We have a plus sign in the front, and in the place of k here, we let k be a -1. Okay, and then here with h, notice we have a -h, but here we have a +4. So h in this case ends up being a -4. Now you may say, wait a minute, Ms. Gable, because that's a +4. Well, think about this as being, oh shucks, I need a little place to write. If I took just that parentheses, x minus h, and I took and did a rewrite on this, because we had x +4, that is x minus a -4. And remember what I keep telling you, in this class we won't do minus or negative, it should be positive. Okay, so in this case, in the place of h, we have a -4, and that's why we go to the left. So let's put it all together. It said in our directions, describe the transformation of the parent function to the function g of x, then graph each function. Well, I went ahead and did the graph, and now we're going to describe it. So in short, my description is that we went vertically down 1 and horizontally left 4. So give me a second to write that down. Kind of running out of time here. So we did a vertical shift down 1 unit, that's our -1, and we did a horizontal shift left 4 units because there's a minus sign built in there. Okay, so this is going to be our full transformation description. Okay, so if you have any questions, please let us know. Okay, so hope you have a great day. This is just example number 1. I'm going to do another one and take a few shortcuts. Okay, have a nice day.